vinyl cutter, of course, like all of you know the vinyl cutter, and you can make not only stickers with it, but also printed T-shirts. And we have also here everything necessary to make flexible circuit boards. It used to be a mystery for me, but actually it's quite easy. So this epoxy tape that is on the Fab Academy inventory, it's actually heat resistant, so it's close. I think it's similar to the Kapton tape. I think it can resist. It was really hard to find the data sheet for it, but as far as I remember, it can hold up to 150 degrees. So basically, if you use this as a base and then you put the copper on it, then you can put all of that into the vinyl cutter, and then from any electronics design software you can export an SVG, and of course with the vinyl cutter you can cut vector graphics. So here we use Illustrator with this Roland Cut Studio plugin. And so you take this SVG, you import into Illustrator, and then you send the commands to the vinyl cutter, so it cuts the copper, and then you remove you weed out the things that you do not need, and it's basically ready for soldering. Another thing that you can do is actually you can cut the solder masks also out of this material. So in any electronic design software you can export the solder mask as a separate layer, also as a SVG vector, and then you again do the same process, Illustrator, vinyl cutter, you use the so this epoxy tape as the material, and then you get a sticker that you can put on your circuit board. Actually, it doesn't matter whether it's flexible or it's the actual circuit board, and it works as a solder mask. So it keeps the traces that are not actually meant for soldering components on them protected. So it kind of improves the longevity of the board. It of course adds up to the process, like it adds some time to it, so not too many people do it. There was only Wendy who was working with, she was making a glove, kind of interactive VR system, and then she made flexible circuit boards to be attached to the inside of the fingers of the gloves. So that needed to be strong enough so it can survive like at least 10, maybe 50 times. And then this approach with the solder mask, it worked quite well. So it was we were able to keep the copper down for so the glue for this tape. It's really sticky, and yeah, it's some sort of epoxy mix or something, and it's probably the glue is also heat resistant. And yeah, I haven't been exploring much into further into the specifications of the tape. I just know that it's heat resistant. So yeah, these are the secrets of flexible circuit board making. And then here we have a 3D scanning station. Here, so this is a little station for working with Raspberry Pis and other kind of single board computers. So you see there's a keyboard, a mouse, a monitor. So there's also like a bigger monitor that actually I took home as my work monitor during the Corona. So I still have to bring it back. And then here, yeah, I'm particularly excited about the 4K capabilities of the new boards. Like Raspberry Pi 4 now has two 4K outputs on one board, so which means, and yeah, I tested them, and it's crazy. Like entering the terminal mode, booting up the Raspbian operating system Lite, so with terminal only on a 4K screen. Very nice. And here have a station for 3D scanning. Actually, for that we have two computers here. So these two arrived a week ago. And so this corner is for processing the point clouds that are then generated with the 3D scanners that we have, and also a bit more advanced 3D modeling. So if you do Fusion or SolidWorks or Rhino or Blender or whatever, or FreeCAD, and you're working on a complex model, then it's nice to have a bit more sophisticated computer. So on these, we ordered with a bit higher resolution monitors. So this is not 4K, but this is more like 2K. So these are This is two full HD resolution, so it's a bit more detailed. So we're working on something really complex, and I think this is giving you a better insight into what's going on in your design. So this is the Regal LiDAR scanner. So with this you can scan interiors and also exteriors. So it's used in wide variety of industries. So starting from film to architecture to civil engineering. So people are mounting this to helicopters and flying through electrical pathways in order to figure out in which places the trees are too close to the cables and so on. And then the people from the movie industry, they actually do use this for location scouting. So for example, instead of sending 20 people to a place in order to explore a space, they send a team of 3 which are operating this LiDAR. So they do they scan the actual locations, then they bring it back to the studio, and then in-house they actually do all the the planning about what the shots are going to be, so where the camera is going to be placed, how many people, so what kind of obstacles have to be taken into account, what are the lighting conditions and so on. But here we have been using it for architectural purpose, so it has been used just for a few workshops. I think Jason was involved into scanning one of the underground tunnels here in the campus, so some of the engineering buildings are actually connected with secret tunnels. Probably this building as well is connected to some secret base somewhere in the center of the building. And one of the next things that we're gonna do is to use this scanner in order to scan rooms of a castle. So there's a team who was participating in a contest which was organized by the same funding program that was used in order to purchase this scanner. So that team is about to create a VR escape room experience where they're going to be, I don't know whether it's going to be really escape room, but they're working on an experience where they want to actually scan the interiors of an actual castle and then transfer that into VR space, and maybe some interesting things within VR with the castle. Maybe like implement or integrate some hidden treasures there, and make it as a game. Or let's say make it so that one room just suddenly transforms into another, and so that you can teleport into rooms. Yes, this is a nice machine. And we tried it here at the lab, and it has quite high resolution, but yeah, I just don't have all the files at hand, so I'm not going to show it now. But this one is a really sophisticated handheld scanner. So actually this table is kind of tricky. It looks modest. It's like this wooden table. These things are a bit scratched and dirty around, but this guy is 65 grand and this guy is 25 grand. So it's like I think so when they arrived, then it was a bit scary, but you get used to it. And this is really nice because so we have also the Arctic Eve, so which is a cheaper model, so which is a 15,000 model, but it has cables connected, and it's quite hard to move around objects. I mean, the proper scanning technique with these is also that you don't need necessarily to walk around the whole object in one go, so you can actually capture several scans, and then what is good with these scanners is that the software is really good and really sophisticated. So the Arctic Studio, now they have version 16, but we have a license for the version 15. It's really good. It has all the algorithms that you need in order to merge all these scans together. So you take a scan from one side, then you go from the other side, take another scan, like 3, I think like the optimum is 4 or 5 scans. And then you do some cleanup in the software, and then you just use the align function, and it does all the magic for you. And then, yeah, you can optimize the mesh, you can do this and that, and then you can export it into an actual mesh. You can 3D print it, or you can use it for 3D animation, so you can import a 3D model with all the textures into Blender. You can add bones and inverse kinematics and start to animate it yourself, like all these kind of things. And this is we're gonna try tomorrow.
Nice.
So
Can we try that at some point tomorrow, perhaps?
Yeah, there's 1 hour that I scheduled for this. It's probably gonna take more than 1 hour, and then maybe we're gonna skip the KiCad part, but we can just work with this a little bit longer.
So with this one, it actually is like you take a few pictures and then you push a button. Because every time when people come to 3D scanning with our little sketchy scanner, I always say like it's not that easy. But with this one,
Like each of these, yeah, they have their own tricks, and you have to know the flow. So we also in the locker over there, we have also the Kinect, then we have also the Intel RealSense. I still haven't really figured out the best way how to scan with Intel RealSense. So there's software that is compatible with that. But you know, either you get only the point cloud, or you know some restrictions. So yeah, I think like for the Fab Academy, I'll need to kind of try again to check, you know, reiterate the RealSense thing, and then everybody who is participating in the Fab Academy is going to know about that. Hopefully, because there are a lot of people who want to share stuff. So, what's next? So here we have a very sophisticated label printing machine. So this is very useful for like all the electronics things. So the electronics library is an ongoing project, and whenever you have 15 minutes, then you know I'm always thinking, how about I make a label, you know, for something that is not labeled yet. And then of course the coffee machine, so which is yeah, I told to some of you already, it's as complicated as a vinyl cutter, and it's really useful to kind of learn how to use it, because it makes your life with the Fab Lab much better, much easier, much more enjoyable. So this I set up as a, you know, kind of a lecturing workspace over here. So when we are having the lectures, either hybrid or on-site, then it's usually I tend to hide on behind the screen, and then you know the actual content. I'm using a lot of demos in my presentations, you know, like maybe some of you have seen the videos that we produced this in last year. You know, it's a lot of doing things in FreeCAD and KiCad, then live coding, and also how to use Bootstrap and how to use Git and all of these. So I'm usually here, and I'm also trying to use the same time for recording what I'm doing. So before doing the lecture, I rehearse, and then I activate it, set up the studio and record it. But tomorrow morning I'm gonna dive a little bit more into details about that. Then let's go here. So here we have the SLA 3D printing station. So we have two printers, Form 2 and Form 3. So the way we manage those is that we choose the resins that are more or less permanently installed here. So unless a student has a reason to use a new cartridge for, like, to make a lot of prints with a specific kind of resin, we're just using the ones that are installed here, because it's a messy business to change the cartridges and all of that. So as you see, it's relatively clean. So I'm kind of proud of that, because you know, most of the people who come here and who own a Formlabs printer, they say, wow, so how is it possible? Yeah, somehow we manage. So I think like the key is really to use only these two resins. So here we have Tough 1500 installed, which is a really nice one. You can make these flexible, stringy parts. They are really tough, and they are also flexible. So yeah, you can check it out. And then and the other one is just basic white. So here, basic white resin. So most of you, I think, know about it. And
These are the only two materials that you are using normally?
Yeah, normally. So there were also chemical engineering students who wanted to have more chemical resistance. So we got the rigid 10K for them. And so it was chemically resistant, but it's very brittle. So we basically did a few prints, and now you know the cartridge and the tank. So with the new resins, it's also that you need not just the cartridge, but you need to change the tank as well. So if you don't want the resin to be contaminated with something else,
We
in a way,
usually use tough.
yeah, tough, yeah.
Yeah, it's always in the printer. Nobody changes it anymore.
I think that's the right approach. And then, you know, if somebody wants to really go into experimenting and has the resources for that, then maybe it's a startup or a company. Then, you know, these are SLA printers that have been made cheaper and more affordable. So that I think that the company, they can buy the printer and they can have a huge rack of all the resins and they can change them on the go. And it's much easier because then the people, if one person or a team is using the printer only for their purposes, then they know about all the details how to do it properly. So if every new student is going to come here and start changing these resins in their own ways, and they usually forget some of the things, some of the items on the list, then it's just quickly going to become a mess, I guess. And but I love these printers. I mean, they are.
We just got our first SLA printer, and now we need to figure it out how we're going to manage it with the students. So it's
That's
to
one
see how
good
you
tip.
are organized it. Yeah.
And also when you're introducing, then it's nice to have, let's say, we are trying it in a way that before the introduction we have already a print ready, like hanging on the build platform. And then, so we show the flow of setting. So we show first, explain about the printers, the technology. Then we outline the main essential components of the printer, which is the resin cartridge, then the resin tank, and the build platform.
Yeah.
And otherwise there would be too many details for them to digest.
Yeah.
And then based on that, we explain, how the flow works with the preform software. So how we are sending the jobs to the printers. So we set up a job. We show also, how to work with supports. Some tips and tricks, best approaches. And then, it's not even necessary to launch the print. So the print is already there. And then we show the cleanup process. I'm paying particular attention to that because it's really important to keep these things clean from resin. Otherwise, the tools, they're just gone after a while because they become sticky. It just becomes uncomfortable to work with it. And
one thing I always say that even though you have gloves on, don't touch the resin, because if you touch with the gloves to tables, and it's everywhere. So I'm always like, no, don't do this. Do like this and take it off and so on. So.
It ends up everywhere anyways. And then we recently got also this cure station, this form cure. It's really useful. It really makes a huge difference. So we used to have just a box with a UV lamp to cure, and it worked okay with the basic white resin, but it didn't work well with the tough resin, for example. So for the tough, if you check the specifications of the resin, then the recommended curing way is that you also use a little bit of temperature. So one of our students tried to boil. So we have a stove, or we have a stove where we can set the temperature. So we just set the temperature according to the specifications, and then we filled in a little bit of water and then boiled the model and then exposed it to UV light. Worked somehow. It became a little bit flexible, but this is perfect because it can also heat up the chamber to a certain temperature. And it also has the UV lights around and a little rotating platform. You can set the time, the temperature, and we have some settings for recommended settings for the resins here, and in the quality. The end result is really nice. It's not sticky at all. I mean, another important thing is that when you are washing them in isopropanol, I wish we would have also the form wash, which does it automatically, so you would not need to touch the resin at all.
It
So
makes
when
a
you
big difference actually.
Yeah.
In our case,
We have this.
it made a big difference.
Yeah.
Now everything's good.
Yeah.
Before it was impossible to keep it like it is now.
Yeah, so the form wash, then yeah, that's one of that's on the list for the purchases next year, I guess. So then we could purchase that, and then it would become less sticky around here. I think the Forum Labs, they even advertise it as a glove-free, curing or processing solution, so that you can actually, without gloves, you can remove the platform, put it in there, so the liquid resin is being washed away, and then you just put it in the curing station, and then it's done. That's good to know that it's actually working.
Well, in our case, I don't know Ari what you think, but I think it makes a big
Yeah,
difference.
Yeah, basically you don't need to use gloves anymore if you don't want to.
No, I mean, and you keep the area completely clean. You don't need to have this big space. It's much smaller space for cleaning.
Yeah, it's the same size machine as this one. So.
Yeah.
And that's with that, you don't need that much.
Yes. And here we have the electronics library, so next corner. So there are most of the parts that are from the Fab library, and it's an ongoing project. It's just I would love to have 1 month or a few months just to work on this only. I'm kind of trying also to maintain the Fab KiCad library, and it's like work here and there. So in order to, I think, have the best kind of footprint possible, then usually you should test it on an actual board, but there's often not enough time in order to produce the board for each individual component. So yeah, 2 years ago I took over the Fab library from where it was, and it was full of bugs, and I added some automated tests to kind of check, what components are there, whether each of the schematic symbols actually have footprints and vice versa. And I also saw that KiCad is coming up with a new format, so getting soon I'll need to put in a little bit more work in order to actually adjust it to the new format. Yeah, it's just it's fun, but it's basically, in order to do it properly, you should be in a full-time position. And basically, when you're running the Fab Academy, then that's the time when you are supposed to, when you actually feel the most motivation to go into it and add new symbols. So yeah, so this might be familiar to you. That's a laser cutter, and it's 10 years old, but it's still cutting. But we are getting a replacement on January, February. It's going to be the new Epilogue Fusion. I think they haven't really announced that product yet, so but through their distributors we managed to get an offer to be able to purchase that. Extraction system, which luckily is not located in our workshop, so it's really big and loud, so it's sort of painful.
Hello Cindy, who are you?
Hi, my name is Cindy.
Kyllä, eli ollaan Factory-nimisessä paikassa. Aloitellaan lounasta. Vaatimatonta lounastamme. Täällä on burgeripäivä, näyttää ihan mahtavalta.